Okay. Number 4, you say? All right, what do you got?
Wait, it's not that. It's which one is it? I know. Did I say 5.2 June 21?
Yeah.
Let me pull it up. I think it's.
You think it's 5.2 November 21? Let me see.
Oh yeah, 5. I think it's 5.1 November 20. Yeah, I think it's that one.
5.1.
Yeah, it's that one. 5.1 November 20.
November 20?
Yeah.
All right, number 4.
Mm-hmm.
All right. So what do you see? What do you think?
Well, I'm guessing that each of the 1, 2, 3, and 4 have like they each have a probability of 1/4.
Okay. Why do you think so? So basically what they're saying is we're picking a number.
Mm-hmm.
In fact, how many numbers are we picking?
4.
Where it says we're picking 2 independent values, right?
Mm-hmm.
All right, we're picking 2 independent values, and let me see if I can annotate on this thing. So it says we're picking 2 independent numbers, and they're being chosen at random, okay? Now, the fact is that each number has the probability of coming up as 1/4. What basically they're telling you is that they all have the same probability of being picked, okay? So can you give me a situation where something like that is similar to that?
A dice.
Yeah, okay. Now think about it. On a dice, what we've got is we've got 6 possibilities, and each possibility is 1/6, right?
Mm-hmm.
In this case, though, we've got 4. So a couple different ways to think of this is, and I totally agree, the way they've worded this, it makes it confusing. But think of it like this. What if I had a die and it had 4 sides? And then I had another die and it had 4 sides. And I rolled the die twice, okay?
Mm-hmm.
Now, so here's what's going to happen. If I have the one die, 1, 2, 3, and 4, and then the other die, 1, 2, 3, and 4. All right, now, what happens is when I roll the 2 dice, if they're the same, then the random variable takes that value. So for example, in this spot right here, what did I roll?
A 1.
And
1.
So what am I keeping?
It would be 1, right?
Because they're the same. Are you with me on that?
Mm-hmm.
All right, now, in this spot, what did I roll?
A 2.
And
1.
So now in this case, they're not the same. So when they're not the same, what do?
Y is a larger value.
What do?
Always subtract the larger value from the smaller value.
So in this case, 2 minus 1 is what?
1.
Exactly. All right. So then what's this one going to be?
2.
And what's this one going to be?
3.
All right. Take a minute and write that down. So now, inside the middle here are all the possible outcomes for y.
Wait, so how'd you know you had to do that?
How do I know to do what?
Like treat it like a dice, like
Well, and again, if I've got two independent values and they're being chosen, I mean, you could also think of it as a spinner. I mean, basically what they're saying is I'm picking two values independently, and I need to figure out all the possible things that could have happened. So I mean, I could have done it any number of ways. I could have said, okay, well, I could get a 1 and then a 1. I could get a 1 and a 2. I could get a 1. I mean, just by kind of writing it. Do you see what I'm talking about?
Yeah.
But the other thing is, I mean, I'm just kind of liking it to something we've done before, like with dice, or what if it was a spinner? What if I had a spinner and there was 4 spots on it? Each thing would have a 1/4 chance of happening. Each thing, if I spun it twice, then I could get these different possible things of happening. So, I mean, I guess what I'm saying is, yeah, I get it doesn't look like something you've seen before, but when I saw it, I thought about what it is very similar to that I have seen before. The dice would be 1, 2, 3, 4, 5, and 6, and it would have 1/6. We've done lots of these with the dice. And so all I did was kind of say, okay, well, what if it was a die and there was only 4 sides? What would this look like? And that's how I kind of set it up. Because it's possible that when you get on this exam, that you're going to see something and it's not like exactly like something you've seen before. But if you can look at it and then say to yourself, well, but this is kind of the same thing that we did do, you know, maybe you can kind of, you know, make it work.
Yeah.
All right, so now what?
It says that we have to draw a probability distribution.
Keep in mind, inside here are all the possible values for y. So what could y be?
1, 2, 3, or 4.
And then what's the probability of each thing happening? What's the probability of it being a 1? How many 1s do you see?
7 out of 16.
So then that's going to be that. And again, do you see how, except for the fact that it's 4 instead of 6, it really is acting just like when we were doing a dice, right?
Yeah.
How many 2s do you see?
3. Oh, no, 4. No, 5.
Yeah, you have to be careful, right? But there's 5 of them out of 16. And then how many 3s do you see?
3 out of 16.
3 out of 16. And then how many 4s do you see?
1 out of 16.
Just 1. Now, what can I do to kind of do a quick double check?
We can add them all together. The probability.
Yeah, what's 7 plus 5?
12.
And then 12 plus 4?
16.
Which, just because it adds up to 1 doesn't mean it's right. But if it didn't add up to 1, well, it would definitely be wrong. Does that make sense?
Yeah.
All right. So that's probably distribution table. Now, what else do they want to know? Find the probability that y is equal to 2, given that y is even. How can I go about doing this?
Wouldn't we use a table to answer this?
You could. So what are we trying to find the probability of?
That y equals 2, given that y is even.
All right. So In this case, what's happening is they've actually reduced the number of things I got to care about. All I got to care about are the even numbers. This is an even number, even number, even number, even number, even number, even number. Yep.
Mm-hmm.
All right. Now, those are all the possible even numbers. What's happening is they want me to find the probability that y is equal to 2, but they're telling me, listen, it's a fact that y has got to be even. So that means I'm not even going to look at non-even numbers. So how many 2's are there out of these numbers?
5.
And then how many even numbers are there?
6.
And see, that's one way to go about doing this. The other way I could do it is I could use the conditional probability. Remember the probability of it being 2, given that y is even. And see, the way I do that is I put down the probability that it's 2 and even, which is easy because 2 is going to be even, right?
Mm-hmm.
And then I'm going to divide it by the probability of it being even. How many evens are there?
6.
All right, so again, so the probability of it being even. One way to do this is take the probability of both and divide by the probability of the given. So the probability of it being 2 and even, well, that would be 5 out of 16. And then the probability of being even, well, that would be 6 out of 16, right?
Mm-hmm.
And see, if I divide by this, well, I'm going to multiply by its reciprocal, right?
Yeah.
What happens to my 2 16s?
They cancel out.
And what's going to happen is I'm going to end up with
5 out of 6.
5 6. So you can use the formula, but you see how, did I have to? Like you said, can I use the table? I totally can, but you just have to understand what they're telling you. If they're telling you that we're given that the y is even, then you can forget about all non-even numbers.
Yeah.
Or you could use the formula and you're going to get the same result.
Yeah. Oh, yeah, that makes so much more sense.
All right, cool. Is there another part to this one? Nope. I'm going to get rid of that, okay? What else you got? Any other ones for this test? Well, we got it here.
I think, well, I haven't finished the last 2 questions.
On this test?
Yeah.
Let's take a look at them. So that's what, 6 and 7?
Yeah.
All right. So what's it say to do?
They want us to draw a cumulative frequency graph.
Okay. And what have they given us?
The cumulative frequency, like.
Yeah, you'll notice how it's a cumulative frequency table.
Mm-hmm.
All right. So let's go back and think about this. What would, if this had been like just grouped data, what's the smallest thing the time could be?
0.
So this would go from 0 to 20, right?
Mm-hmm.
And this would go from what?
20 to 30.
And this would go from?
30 to 40.
And this would go from?
40 to 60.
And this would go from?
60 to 100.
Now, quite honestly, most of the tables that we saw and did problems with in the book, they gave them to us that looked like this, where the data is being grouped, right?
Mm-hmm.
And in this case, they're actually trying to save us some work. Because if I was doing this cumulative frequency graph, I would have to find all these cumulative frequencies. They've already done it for me, okay?
Yeah.
So now all I gotta do is identify the points. And if on the test, on the exam, you want to make sure that you write down the points somewhere so somebody knows that you're absolutely know what the points are. So what's the first point going to be?
0, 20.
No.
Well, no, 0, 0.
Exactly. What's going to happen is you're going to take the lowest possible number and then make it 0. Why? So my first point is going to be 0, 0. Now, if this had gone from 5 to 20, well, then my first point would be 5, 0. If this had gone from 10 to 20, well, then my first point would be 10, 0. Does that make sense?
Yeah.
It won't always be the origin, but don't be surprised if it is. All right, so then what's my next point going to be?
30, 48.
Again, we got to do this one first.
Oh, wait, 2012.
So yeah, exactly. 2012, then what?
30, 48.
And then what?
40 and 106.
And see, all that I'm doing is I'm taking the upper value for each class, and then I'm attaching to it the cumulative frequency. And like I said, if they had written the table where it wasn't all added up, I would have had to add all this stuff. They'd actually saved me a little bit of work. What's the next point going to be?
60, 134.
And then?
100, 150.
All right, those are my points. All right, now we got to figure out what we're going to do with our graph, okay? So what is that going to look like? Oh, you know what? This is going to move. Oh, I don't like that. All right, we're going to go up here. Let me see if we can make this smaller. Okay, so first, count them. Well, how about this? Which one of these rows are my x-axis?
The time.
And which one's the y-axis?
The cumulative frequency.
And see, one of the things we're going to do first is we're going to label this stuff. So this is going to be cumulative frequency. You could just put CF or something like this. You could abbreviate it. If you put something like this, they're going to know cumulative frequency, or CF, even CF, they'll know what that is. And then what goes along here?
Time.
And again, what's it time measured in?
Minutes.
And see, that's important that we put that, okay? All right, so take a look at my x-axis. The smallest value is 0. What's the biggest x value?
100.
So if I go 10, 20, do you see how that seems like that's going to go work out pretty good? Now, the other thing is I don't got to write every single one. If I wrote this 20, 40, 60, 80, and 100. And again, keep in mind, you need to write enough stuff that you can see what's going on, but don't get all super like detailed about it, because you need to write this. You need to make this thing as fast as you can. Does that make sense?
Yeah. So
then tell me about my y-axis. It goes from 12 to 150, right?
Mm-hmm.
So again, you see, if I count these, I'm going to get like 15 or 16 of them. This is almost set up for me basically to do this by tens. So again, if I were to do this 20, and then 40, and 60, and 80, whoops, and then 100, almost didn't do that right, 120, and then 140, and then 160. Are you with me on this?
Yeah.
Sorry about my points in the middle there. Okay, so now all I got to do is plot my points. So what's that going to be? 0, 0. And then 20, 12. And see, the nice thing about this is each one of these blocks is going to be 2, right?
Yeah.
So 2012, I can find that point pretty close. And then 30, 48. 30, 48 is going to be 2 right here. And then 40, 106. That's going to go 2, 4, 6. And then 60, 134, that's 30. So this is going to be 2, 4. And then 100. And then 150, right? Oh, wait, did I not do 60? I screwed this up somehow. I did screw this up. Hang on. This point is actually going to be 160. So this is going to be 60 and then 134. So that's going to be closer to that. And then 100, 150. It's going to be like that. And then keep in mind, you're not going to have a ruler, but you will have that formula booklet. And so what you want to do is connect each one of these points with a straight line. And again, use that booklet as like a little mini ruler. Again, you don't want to spend tons of time on it, but you also do want to make sure that, you know, you're not making it super wobbly either. Now, it's not going to go any further than that point. Okay? All right. Now, we've got labels, right?
Yeah.
I've got a constant scale on both the y-axis and the x-axis. I've got the points. And again, notice, like I said, by writing these points on the paper, this person on their rubric is going to have a general probably shape, or they may have the points written down. And the thing is, if you just plot the points, you're making that guy go and look at every point to make sure that you did it right. Here, I've got the points, and clearly I know what I'm doing. And then all he's got to do is make sure that they kind of make sense. Yeah?
Yeah.
All right. So that's that first part. Now, what does B say to do?
Besides two, it wants us to find the estimate value of K.
And what do we know about K?
24% of the students take K minutes or longer to complete the challenge.
All right. So 24% take more time. All right. Now, remember what goes along my y-axis.
The cumulative frequency.
And keep in mind, the frequency are actually students, right?
Mm-hmm.
Each one of these numbers represent a student and their individual time. Okay.
Yeah.
So 24% of the students take this much longer to do the challenge. Okay. So the students are over here on my y-axis. Now, the thing is, 24% of them are above it. You with me on that?
Yeah.
So think about this number here. How many students do I have altogether?
100, 150.
150, okay? Now, if I multiply it by 0.24, what am I going to get?
You get 36.
That's all the way down here, okay?
Mm-hmm.
Now look at my students. Do you think that 24% of the students are above me?
No.
Okay. In fact, what's happening is 24% of the students are below me. How many are above me? What's 100 minus 24?
76.
All right. So in this case, if I were to do 50 times 0.24, I'm going to get the spot that has 24% below me. I want to have 24% above me. So I'm not going to multiply the 150 times 24. What am I going to multiply by?
0.76.
Because now what's going to happen is how much of it's going to be below me? 76, which means how much is above me?
24 would be above.
All right. So what's 150 times 0.76?
114.
All right, so now what happens is I go to that 114, which this is 100, this is 110. So this 2 blocks up is going to be 14. And then I come over here and I go to the graph. Are you with me on that?
Mm-hmm.
Now, I know it's kind of small, but do you see how it looks like it's 1, 2, maybe 2.5 blocks away from this solid line here?
Yeah.
Anyway, and then I'm going to come straight down, but it's going to be about 2.5 blocks. All right. So this is going to be, or actually it looks like it's pretty really close. So 40 plus 2 plus 2, that's going to be 44, right?
Mm-hmm.
Okay, is going to equal 44. And I don't have the rubric in front of me, but my guess is there's a little bit of wiggle room on this.
Yeah, that makes sense.
Okay.
Mm-hmm.
Now tell me about C. What does C say?
It wants to calculate the estimate of the mean and the standard deviation of the time taking place to complete the challenge.
All right. So now I'm done with this cumulative frequency, right?
Mm-hmm.
So I'm going to go back here. Let me see if I can get rid of this stuff. Eraser. All right, so now what's going to happen is they're asking me to find something. And now I need my table, not as a cumulative frequency table. I need it to be grouped data. Now we've already started writing it, right?
Yeah.
So tell me, what are my numbers going to be down here? We already said that this group data is going to go from 0 to 20 and then 20 to 30, right?
Mm-hmm.
All right, so let's see if I can make this bigger. All right, so there we are. And there's our groups. Now, if I just want to change this to frequency, what's the frequency for the group 0 to 20?
Wouldn't it be 12?
It's going to be 12. Exactly. Now, what's the frequency, not the cumulative frequency, but the frequency for 20 to 30?
That would be 36.
Because it's going to be 48 minus 12, right?
Mm-hmm.
This number includes the number in this group plus the 12. So 36 plus 12 equals 48. What's the frequency of 30 to 40?
58.
Because 106 minus 48 is going to be 58. Then 40 to 60 is going to be what?
28.
And then what about my last one here? What's 150 minus 134?
16.
All right. Now, they want to know what?
They want to know the mean and the standard deviation.
All right. So how do I find the mean? How about this? If it was a probability distribution table, how would you find the mean?
You'll multiply the number of things to the probability.
Exactly.
Yeah.
Okay. Now, we did this a while ago, but it's really similar. The problem we have is we don't just have one number up here, do we?
We have multiple.
We've got a whole group. What number am I going to use?
Oh, use the mid class, right?
Right. So What's the mid-class value from 0 to 20?
10.
And then what's the mid-class value from 20 to 30?
25.
And then what's the mid-class value from 30 to 40?
35.
And then from 40 to 60?
50.
And then from 60 to 100?
80.
All right, so a couple points before we go on. Notice how it starts off, this one's pretty straightforward. Then this one goes by 10. And then this one is 5. I mean, but do you see how it shifts around? You have to be careful and not think that there's a pattern. I mean, they're all different. Does that make sense?
Yeah.
All right, now, what am I going to do? To find the mean or the expected value, I'm going to take each mid-class value times its frequency. Because think about it. How many times did this 12 happen? Or how many times did this 10 happen?
12.
It happened 12 times. So I could write 10, 12 times, or I could write 10 times 12. It's the same thing, right?
Mm-hmm.
Because what I'm doing right now is I'm finding the mean, which if you think about the mean, I add up all the values and I divide by the number of values, right?
Mm-hmm.
All right, so again, I have 25, but there was 36 of them. So I'm multiplying it by 36. I've got 35, but I have 58 of them. Yeah, that looks messed up. $35. And then I've got 50, but I got 28 of them. And then I've got 80, but I've got 16 of them, right?
Yeah.
Now, the thing is, that's me adding up all the numbers. But then what do I have to divide by?
150.
Because that's the total number of numbers, right?
Mm-hmm.
Now, I'm going to write all this stuff, but what am I going to do? I'm going to have the calculator do all the work. So you got a calculator with you?
Yeah.
Turn it on. Push menu. Do you know where statistics is?
Yeah.
Which one is it?
6.
Exactly. All right, now we're going to go to number one variable statistics, right?
Yeah.
Now, do you have a place for a number and a frequency?
Mm-hmm.
What number are you going to put in there?
You're gonna put 10, 25, 35, 50, and 80.
Right? Okay, then what frequency are you going to put in there?
12, 36, 58, 28, and 16.
All right, do that. After you enter all your data in, how do I get it to give me the calculations?
Don't you do shift calc?
No, right next to it. Do you see the option button?
Oh yeah, option calc.
Push option, and then you should see one variable calculations, right?
Yeah.
Number 3, click that. All right, now there's all kinds of information there. If I wanted to know the sum of all the x's, what's the sum of all the x's?
EX.
Nope. Yeah. Oh, yeah. What is it? What's that number?
5,730.
And then if I wanted to know the sum, well, I already know what this is, right? It's 150, right?
Mm-hmm.
But do you notice how they have n on there, or what some of the frequencies? If you go down, n is 150. Okay.
Yeah.
And if I divide that, what do I get? What is the mean?
38.2.
Okay. Now that's the mean. Now, how am I going to find the standard deviation? Is that what they asked for, or variance? Standard deviation?
Yeah.
How do I find that?
You can.
What I'm going to do is I'm going to find the variance first.
Yeah.
Now, it's going to be very similar, but instead of 10, what's it going to be?
It's gonna be squared.
So it's going to be 10 squared times 12 plus 25 squared times 36 plus 35 squared times 58 plus 50 squared times 28 plus 80 squared times 16. All right, now that's all going to be divided by what number?
150.
150 again, but then I have to take away something. What do I have to take away?
The mean squared.
So I'm going to write 38.2 squared. All right, now that's going to be the variance. Okay, now the thing is, you still have your calculator open?
Yeah.
What's the variance? Which one is it?
The OX.
Yeah, so what's the variance going to be?
17.93.
Oh, no, take it back. That's the standard deviation. What's the variance?
Oh, the variance?
See where it says, oh, it's theta. I
Yeah.
mean, a sigma, little sigma, but you
Mhm.
see how it's squared?
Yeah.
That's the variance. What's the variance?
321.76.
Okay, notice how you don't have to retype it in. It's already in there, right?
Mm-hmm.
Now that's the variance. And so now what I'm going to do is tell them what the standard deviation is. And the standard deviation is going to be what?
17.938.
Which if I round to 3 figures, it's going to be 17.9, right?
Mm-hmm.
Now, what happens is they need to see this work. The calculator clearly can do it all, and you don't even need to actually write any of it down, except for if you don't write it down, then you're not going to get the method points. So writing this down and writing this down, but then notice how we've got all the answers from actually getting from the calculator.
Yeah.
How's that? Pretty good?
Yeah, sounds good.
Is that the only part for that one?
I think so.
All right, awesome. And then you said you didn't do the next one either?
Yeah, number 7.
Let's take a look at that one. Here it says, find the number of different ways for the word shopkeeper. Oh, you know what? Someone was laughing about this today in class. Cameron was saying she hates this one. All right. Find the number of different ways in which 10 letters in the word shopkeeper can be arranged. So when you see the word arranged, what am I thinking?
That factorials, you're thinking about that?
I'm thinking about permutations.
Yeah.
Because there's two possibilities. Either we're going to be talking about permutations or combinations. If I see the word arranged, then I know that I'm now thinking about permutations. If I see the word choose or select, or if there's something going on that involves choosing or selecting, then I know I'm using combinations. A good keyword for permutations is arrange. All right. Now, what's the requirements?
That all 3 E's are together.
All right, so let's do that. E, E, E. All 3 E's are together, yes?
Mm-hmm.
Now tell me, are there any other duplicated letters?
Yeah, P.
I'm going to put them, how many P's are there?
2.
All right, I'm going to put them together, okay? Now, any other letters that are the same?
Nope.
So let's see, we've taken care of our E's, right?
Yeah.
We've taken care of our P's. It looks like we now can go S, H, O, K, and R. Yes, you with me on that?
Yeah.
Now here's what I'm going to tell you. How many letters are here in this word?
10.
If you're going to rewrite it, and I sort of suggest that you do, you need to make sure that you still have 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to also be careful about this rewriting, because all you got to do is make one mistake and there's nothing you're going to do to make it right. So it's, if you know, you want to not spend an hour doing this, but the thing is, rewriting it is going to help you, but it only helps you if you do it correctly. Now, what letters do I need to put together?
E. The 3s.
All right, so I'm going to count them like this. Now, the first thing, whenever I have a group that are together, I need to figure out the number of ways that they can be arranged. What's the number of ways arranging 3 E's?
1.
Exactly. Okay. Now, if they were different letters, then I would have to figure that out. But there's only one way to arrange 3 E's. It's always going to be E. Okay. But I'm going to write 1. Okay. Now, I'm going to count this together group as one thing. 1, 2, 3, 4, 5, 6, 7, and 8. I don't have 10 things anymore. Now I have 8 things. And how do I arrange 8 things?
8 factorial.
8 factorial. However, I've got to make sure that if there's any duplications, what do?
You divide it by.
Now, again, I'm not worried about this E because it's not it's one thing. All right.
Mhm.
I don't have any other EEEs. It's the only EEE I have. However, I do have 2 P's. Yes.
Yeah.
So I divide by 2 factorial. So what's 8 factorial divided by 2 factorial?
Um, 20,160.
Okay.
Yeah.
So keep in mind, when you're trying to keep things together, put them together. And the first thing is figure out the number of ways they can be arranged. In this case, they can't be arranged any number of ways. So we're not going to worry about it. But a lot of times they can be. Like, for example, what if we took this same exact problem, but they said they want the vowels to be together? Well, so now I would have 0 or O, E, right? And then I would still have P, P, S, H, K, R. Now, if I wanted to keep the vowels together, how many ways can the vowels be arranged?
4 different ways.
4 factorial, because there's 4 things, right?
Mm-hmm.
But how many of them are duplicated?
3.
So 4 factorial divided by 3 factorial, yeah?
Mm-hmm.
Now, after I figured that out, how many things do I have in this situation? 1, 2, 3, 4, 5, 6, 7. And I'm going to arrange them 7 factorial ways. But because of these 2 P's, I still have to divide by 2 factorial. Now, in this situation, I'm going to multiply those together. Right?
Mm-hmm.
All right, but that's not what they're asking. So, but anyway, sometimes the together things can be arranged, and sometimes there is only one way. So you got to make sure you're clear about that.
Yep.
All right, tell me about B.
They want us to find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that the P's are not next to each other.
All right, so P's cannot be next to each other. So what are you thinking about that?
Stars and bars.
All right, so what are the stars? Oh, yeah, what are the bars?
The bars are like the spaces that can.
What are the bars in this case? The things that are separating my P's.
Yeah.
What are separating the P's?
Words are not P.
Exactly.
I mean, the letters are not P.
So I could even write the letters, right?
Mm-hmm.
E, right?
Right.
What else?
S.
H.
O.
K. And R. Is that true?
Yeah,
Now, the reason I didn't put any P's, because where are the P's going to go?
they're gonna be separated. Yeah, they're gonna reach.
They're going to be the stars. Yes?
Yeah.
All right, now here's the thing. I'm all about the whole stars and bars thing. I love the stars and bars. However, if I would have written it like stars and bars, it would look like this. 1, 2, 3, 4, 5. What do I got? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it would look like this, right? Stars. Okay, so let's look at our stars and our bars. What am I going to do first with my stars and my bars?
You need to find out how the number of ways can be arranged.
The bars.
Yeah. the bar.
Okay. Now, the problem is when I look at this written this way, it looks like they're all bars, right?
Right.
Now, look at my letters. How many different ways can these non-P's be arranged? How
Eight.
many of them are there?
8.
8 factorial, but how many of them are duplicated?
3 of them.
And I've got to make sure I divide that by that. And see, the problem is when I use stars and bars, I might miss the fact that they're duplications. You with me?
Yeah.
All right. Now, what am I going to multiply by?
The numbers base.
The places that I can put my P's, right?
Mhm.
What are the possible number of places?
9.
There's 9 places they could go, but I don't have that many. How many do I have?
2.
So I'm going to do that. Now, again, the other problem is that are there any duplicates in my stars?
Yes.
They're both P's, right?
Mhm.
So what do I divide by?
2 factorial.
Okay, whenever you're arranging something, whether you're using P or factorial, you always divide by the number of repeated items. So now all I'm going to do is multiply that together. And what do I get?
You can get 725,760.
You did 8 factorial over 3 factorial?
Oh no, I did 2. My bad. I got 241,920.
Okay. So now we got that taken care of. Now, what about C? Let me clear this out. You good with those?
Yeah, I understand that.
All right. Now, again, I want you to understand, these are 2 very common concepts. Arranging things with a group together, and then arranging things where things cannot be together, okay? Now, the other thing is, keep in mind, now there's only 2 P's, right?
Mhm.
If there was more than 2 P's, or if there was more than 2 letters that they wanted to keep together, you have to be careful because sometimes they're going to say, I don't want them all to be together. And if they don't want them all to be together, what I'm saying is I don't want all 3 or 4 of them to be together, but I'm okay with 2 of them to be together. In this case, though, it's pretty clear they have to be separated because there's only 2 of them. All right, let's see. What do we got here? Now what's going on? In C, find the probability that what?
That a randomly chosen arrangement of the 10 letters of the word shopkeeper has an E in the end and the E in the beginning.
All right. So again, now we've got, once again, it's an arrangement. However, it's a probability. And so what's going to happen is that sometimes they're going to ask you to find the number of ways for something to happen. And sometimes they're going to ask you to find the probability. And keep in mind, all probabilities are the number of ways that I'm interested in divided by the total number of ways. So I still am going to find this, but I got to make sure that my answer is not a number of ways, but it's a fraction. Anyway, we're going to still start by doing this. I've got 10 letters, right?
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what are the requirements?
There has to be an E in the beginning and in the end.
There's an E in the beginning and an E in the end. Okay. Now, I now only have the letters S, H, O, P, P, E, K, R. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes?
Yeah.
Okay. Now tell me, what's always going to be at the beginning?
E.
And what's always going to be at the end?
E.
So in all these arrangements, they're not going to change. Okay?
Yeah.
So all I need to worry about is what these middle spaces are going to be. They're the things that are going to change. And the number of ways I can fill in these middle spaces will be the number of different arrangements there can be. So how do I figure out the number of ways I can fill in these middle spaces?
You do.
How many letters do I have?
8 factorial.
All right, 8 factorial. Now, how many are duplicated?
2 of them.
So I've got to take that into account, right?
Mm-hmm.
So how many ways can that happen?
20,160.
All right. That's the number of ways that I can have an E on each end. Yes?
Mm-hmm.
All right. Now, tell me about the number of possible ways to arrange the word shopkeeper. How many letters are there?
There are 10.
How many repeats are there?
There are 2 repeats. So 2.
2 P's and how many E's?
3.
And again, I'm going to use this fraction function of my calculator, so it stacks up. This is the total number of ways to arrange the letters in the word shopkeeper with no restrictions. This is the total number of ways to arrange the letters in the word shopkeeper where there's an E on each end. This is what I'm interested in. And this is going to be the number of ways, the total possible ways of arranging the word shopkeeper. What's 10 factorial divided by 2 factorial times 3 factorial?
302,400.
Now, my answer is this fraction. What is 2,000 or 20,160 divided by 302,400?
Oh, 115.
Now, the other thing is that in a situation like this where you get to talk about a fraction, I mean, just leave your answer as a fraction. Don't worry about changing it to a decimal. Don't worry about 3 significant figures or anything like that. If your answer is a fraction, just leave it a fraction.
Do we have to simplify it?
1 over 15?
No, the 20, like the before it was 1 out of 15.
Say that again.
Like, do we have to like simplify the answer?
Well, this is our answer.
We can't just leave it like 2,000.
You could. Oh, you could. That's a good question. My guess is if you wrote that, if you wrote the fraction 20160 over 302,400. I mean, my guess, and we'd have to look at the rubric to be sure. My guess is they probably would accept it because more than likely that it says 1 over 15th or equivalent. And this is definitely equivalent. But I tell you what, I would write them both. I would write this and then write equal 1 over 15. If for some reason you screwed this up, if they see this, they should still give you credit for it.
Mm-hmm.
But like I said, the answer on the rubric is probably going to be this. And again, when you're talking about this test, you want to make it easy for the grader to see you have the right answer. Don't make them work for it. So could you possibly not do it? Yeah, but let's face it, it really isn't that hard to do. And as long as you're careful, you're probably going to get the right answer. And this is actually the number that he's going to be looking for. And it would be silly. This is only worth 2 points.
Yeah.
It would be silly to do all this work and then only get 1 point when all you really had to do was divide it and figure out that it was 1/15.
Yeah.
All right, you good with that?
Yeah.
All right. So now, take a look at this one. What's going on now?
They want to find the number of different selections in the 4 letters that include exactly 1p.
So what's the key difference here?
It uses the word selected.
And see, now I know that we've shifted gears. And now I'm talking about combinations. Okay?
Mm-hmm.
Also, and so sometimes in these problems, what happens is things you've done before, you need to use in the next part. But here we're completely shifting gears. All right. So we're now talking about combinations. 4 letters are selected from the 10 letters of shopkeeper. Now, here's the big thing. When you're doing permutations, if they're repeated items and you're doing arrangements, then all you've got to do is divide by that number factorial. Yeah.
Mm-hmm.
However, the problem is with combinations, there is just no easy way to do that. You can't just, oh, there's some repeated letters, I'm just going to divide by this. What happens is I've got to write down the different scenarios that could possibly happen. So first, what are the requirements? I want the different selections if the 4 letters include exactly 1p. Yeah?
Yep.
So 4 letters. 1, 2, 3, 4. But it's given to me that there's 1p. Okay? So now, how many letters could I put in the other spaces? What letters are available?
S,
S,
H, O,
not P. What else?
the 3s.
Well, I'm going to do a K because I happen to be getting there. But then you're right, the 3 E's, right?
Mm-hmm.
I'm going to put them together to remind myself there are that many of them. And then again, now what? R?
Yep.
Okay. Now, do you see the fact that there are these 3 E's?
Mm-hmm.
This is what's going to pose the problem for me. I can't just say, oh, there are 1, 2, 3, 4, 5, 6, 7, 8 letters, and I'm going to choose 3 of them. 8, choose 3. Because the problem is 3 of those letters are identical. And so it's going to reduce the number of choices I have because some of the letters are the same. Does that make sense?
Mm-hmm.
All right, so here's what I'm going to do instead. I've got to rewrite every scenario that's possible. Now, the first possibility is, what if there was no E's?
You would do.
If I talk about my 4 letters not having any E's, now what letters do I have to choose from?
S, H, O, and K and I.
And how many is that?
5.
All right. So if there are no E's in this 4-letter word, then now I can say that there's 5, choose 3 ways to fill this spot. Yeah?
Mm-hmm.
All right. So now, what if there was only 1 E? If there's only 1 E, well, I need to have a P because that has to, every one of them has to have a P, right?
Right.
But now I have 1 E. Now I still have 2 letters to choose from, but they're not going to be P's or E's. So again, how many letters do I have to choose from?
5.
But I'm only got 2 places. So that's how that's going to go. Yes?
Mhm.
So then what's the other possible thing that could happen? Out of my four letters, I could have no E's, I could have 1 E. What else could happen?
You can have 2 E's.
It's possible that I have 2 E's. And see, do you notice how what happens is because of these duplicate E's, I've got to break down every different scenario. So now, though, there are 5 letters to choose from that are not P's and not E's, but there's only 1 space left. So that's going to be 5, choose 1. Yeah?
Mhm.
All right. Now, the last possible thing is that there are actually 3 E's. If there were 3 E's and there's 1 P automatically, I'm not picking any more letters, right?
Mhm.
And there's only one way for this to happen because I've picked all my E's, yes?
Mhm.
So this is one way. How many ways is this?
5.
This is 5 ways. What's 5 choose 2?
That's 10.
And then what's 5 choose 3?
10.
How many ways do I have altogether?
26.
26 ways. Okay?
Yep.
If I was doing this and there weren't duplicate letters, well, then I wouldn't have to worry about separating all these. The only time, so if you're doing selections and there are duplicates, then what you've got to do is you've got to write down every possible scenario. No duplicates, 1 of the duplicates, 2 of the duplicates, in this case, 3 of the duplicates, and then figure out how many ways that could happen. Does that make sense?
Yeah, I understand.
All right. Now, there's one thing that this one's different, and I kind of want to talk about it though, is that they also do the same kind of problem. And what they'll say is, what's the probability? If this didn't say what are the number of different selections, but instead it said, what's the probability? Well, then I'm going to find the number of things I'm interested in and then divide by the number of ways that it could possibly happen. So let's think about the bottom of my fraction. How many letters are there?
10.
And how many am I choosing?
4.
So the bottom of my probability fraction would be 10 choose 4. Okay?
Mhm.
The problem is that doesn't take into account that I have all these duplicate letters. And the fact is, if I had to figure out all the different ways with 2 P's and 3 E's, it would take me forever. Because, well, think about it. For everyone, you see how there's 1, 2, 3, 4 ways? Now, the reason in this problem up here, they told us that it's going to have 1 P is because it took away a duplicate letter. If they wouldn't have, then we would have had to do all this, but then we would have to also do it with no P's, with 1 P, and with 2 P's. And see, then it gets really tedious and a lot, okay?
Mhm.
So if this question had been a probability question, to find the number of ways to arrange the letters, I would have done 10 choose 4, or not arrange, but select the letters. I would have do 10 choose 4. But that kind of operates on the presumption that all of these are unique. If I was doing this, then the number of ways I'm interested in won't be 26. Instead, how many P's were there?
2.
I would do 2 choose 1, 2 choose 1, 2 choose 1. I would treat each one of these duplicate things as if they were completely unique. How many E's were there?
3.
So this would be 3 choose 1. This would be 3 choose 2. This would be 3 choose 3. Does that make sense?
Yeah.
If they ask you to find the probability, then you're going to take each letter and then you're going to, how many of them there were. But if they just ask you for the number of ways, well, then you're not going to do that. And see, that's really confusing to me.
Yeah.
Anyway, this is the number of ways, and this is the answer to their question. Does that make sense? How we
Yeah.
doing?
Doing good.
All right, good. Were there any other questions on any of the tests?
Yeah, it was one that you mentioned. It was like, I don't know. Wait, I can look it up right now. But it's like when it doesn't want all of them together, like situations like that. I got confused on that. Like we can't have all of their, like, you know how
An
you
arrangement
separate,
one?
yeah, the separation one, but like it's not like all three, you know. So like there could be two rows, but there can't be three, you know. Oh yes, 5.2 June 21, question 6.
June 21, 5.1. This is 5.2. Was that wrong?
Oh no, that's it. Yeah.
What question number was it?
Number 6.
All right. So let's take a look at this one then. Find the total number of ways to arrange 8 letters in the word tomorrow. Tell me what to do.
I did 8 factorial divided by 3 factorial times 2 factorial.
Why'd you divide by 2 factorial and 3 factorial?
Because those are duplicates.
1, 2, 3, 1, 2. 8 letters altogether. All right. That's good, right?
Mm-hmm.
All right. Now, tell me about this next part then.
They want to know the different arrangements of the 8 letters that have an R at the beginning and the R at the end, in which the 3 O's are not all together.
All right. So let's try this. First, we have how many letters? 1, 2, 3, 4, 5, 6, 7, 8. Yes?
Mm-hmm.
Find the total different arrangements of the 8 letters in the word tomorrow that there's an R at the beginning and an R at the end. But the O's are not together. How many O's are there?
3.
All right. So this is an excellent example. There are 3 O's. Now, notice how it says the O's are not all together. That means they don't want to have O. Now, they're okay with having 2 O's together, but
Right.
they're not okay with having all 3 O's together. Does that make sense?
Yeah.
So what makes this different is that I don't need the O's to be separated, because it's possible I would be okay with 2 of them to be together, but they're saying they don't want all 3 together. So what happens is, in this kind of situation, is we do kind of the opposite. Figure out the number of ways that the O's are definitely together. O. Are you with me?
Yeah.
All right. Now, again, keep in mind, out of my tomorrow, there were only 2 R's, right?
Mm-hmm.
And in every arrangement, there's going to be an R at the beginning and there's going to be an R at the end. So that's not going to change. So again, the number of arrangements has nothing to do with these R's, only with these middle ones. So now I don't have 8 things, I have 6 things, yes?
Mm-hmm.
Now, if I want to figure out the number of ways these have to be together, all right, so tell me, what are my non-O letters?
T, M, W.
T, M, and W, right?
Mm-hmm.
Okay, now, how many ways can these O's be arranged?
1.
All right, so that's the first thing I figure out. Now, I'm going to count them as 1 thing, 2 things, 3 things, 4 things. Yes?
Yep.
How do I arrange my 4 things?
4 factorial.
4 factorial. Now, are there any duplicates?
No.
Nope, duplicates. So what's that going to be? What's 1 times 4 factorial?
24.
Okay, now that's how many ways they can be arranged where the O's are always together. Yes?
Mm-hmm.
All right, now what I need to figure out is how many ways these 6 things could be arranged just in general. 1, 2, 3, 4, 5, 6. Because again, there's R's at the beginning and R's at the end, right?
Mm-hmm.
1, 2, 3, TMW. How many ways can I arrange 0, 0, 0, TMW?
6,
Divided by?
3 factorial.
Okay. Now, what's 6 factorial divided by 3 factorial?
120.
This is 120. Now, again, let's make sure we're clear about what's going on. This 120, that's how many ways I can take 0, 0, or 0, TMW and arrange them in any way that I want to. Okay?
Mm-hmm.
This 4 factorial is the number of ways I can arrange these 6 letters, but the O's, the 3 O's are always together. Now, what I want to know is how many ways can I do it so all 3 O's are not together? So I take my 120, which is a total number of ways I can arrange those 6, and take away 24, because in the 24, the 3 O's are together. How many are left over?
96.
There's going to be 96 ways where two O's are together or the O's are completely separated.
So wait, so we find the 6. We did 6 factorial divided by 3 factorial because like that's the different ways they can be arranged, right? Just
That's the way, that's the number of ways. Now, again, keep in mind, because I still need to have an R on each end, right?
Mm-hmm.
So the only thing that's changing are these guys in the middle. So this is the number of ways I can arrange these letters without any restrictions at all. If I just said arrange OOOTMW, how many ways could they be arranged? Well, you do 6 factorial divided by 3 factorial, right?
Mm-hmm.
Now, this is the number of ways where OOOTMW, but the 3 O's are never, they're always together.
Mm-hmm.
So if I take the total number of ways I can arrange these letters and take away the number of ways when the 3 O's are always together, well, then I must be left with the number of ways where the 3 O's are not together. Now, that doesn't mean that they're being separated.
Oh, okay, yeah. That was just confusing me.
So, for example, let's do this. What if the question said, do the same exact thing, but the 3 O's cannot be, they must be separated? Again, I'm going to do TMW, yes?
Mm-hmm.
And then I'm going to do stars, which is OOO, right?
Mm-hmm.
Okay. Now, how many ways can I arrange my TMW?
3 different ways.
3 factorial, right?
Mm-hmm.
And then this is going to be 1, 2, 3, 4, 4, P, and then I only have how many O's?
3.
Right? Okay, now, what's 3? Oh, but how many, I got to divide by what?
3 factorial.
Okay, so what's 3 factorial? Well, what's 3 factorial divided by 3 factorial?
1.
So this is going to be, my answer is going to be 4P3. What's 4P3?
24.
Four P3 is 24?
Yeah, it gave me 24. 4P3.
2, 3. I guess it is, but it ends up being the same thing. Oh, no. So again, this is the number of ways where the 3 O's must be separated. Yes?
Mhm. Yeah.
But this is a number of ways where they could be completely separated, but maybe 2 of the O's are together. Notice how there's more of them.
Yeah.
There's a lot less of them when the O's have to be completely separated. So again, if there's only two things that need to be not together, well, then they have to be separated. But if there's more than two things, then you have to make sure you're clear about whether it says that the two or more thing, three things, four things. If you have three or four or more things, you got to make sure you're clear about whether they're saying it be separating them or whether they just can't be all together. If it can't all be together, well, then find the ways that they can when they are all together, and then take it away from the number of ways they could possibly be done. Does that make sense?
I'm trying to wrap around my head around. Okay, so like you were to subtract it. I'm trying to think about like probability. Is it similar to that? Like, so like, let's say like,
Well, again, we're not doing a probability because they're just asking me for a total number of arrangements.
yeah, like, when trying to like wrap it around, like how does that give you that? Like, how does that work? I get what you're doing, but like I'm just not clicking.
Well, what part's not clicking?
Like I don't get like how doing 120 minus 24 is gonna give you like how like all the three O's are now all together.
Okay, so how we get the 120?
We did 6 factorial divided by 3 factorial.
But why do we do that?
Because that's the
That's the number of ways TMW can be arranged, right?
mm-hmm.
All right, so if that's the total number of ways, no restrictions. If I just want to arrange these letters, it can be done in 120 ways.
Right.
Okay. Now, what's the 24?
That's the number of ways in which the three O's are all together.
That's the ways where the three O's are always together. O's. Always together. All together. Now, what's the question asking?
In which the three O's are not all together.
Not all together. So this is the number of ways they can be arranged. And this is the number of ways when the three O's are all together. If I take 24 away from the 120, well, then these other ways must be the ways when they're not all together.
Oh, okay. Okay, it clicked. It clicked. Yeah.
Sometimes with these kind of situations, they may ask you to find something, and it's actually easier to find the opposite of what they're asking for.
Yeah.
And then take it away from the total number of ways.
Yeah.
All right, you got anything else?
Yeah, I do. I had a whole list.
Well, what else you got?
I got let's see. Oh, I had a question on number 1 as well.
On this one? On this one?
Mm-hmm.
All right, let's go look at that. Whoops, I'm stuck. Okay, so tell me what you think. What do you see?
So I understood like what's going on. So like I understood with part A.
Okay, tell me about part B then.
So part B, that's where I got lost.
All right, so tell me about part A then. Just explain to me part A.
They want the mean of X.
Okay, how did we figure it out?
I did 1 divided by 1/6.
Okay, why'd you do that?
Because it's a geometric distribution.
And that's how I find the expected value for a geometric distribution, 1 over P, right?
Yeah.
All right, so now let's shift gears. Find the probability that a 5 is first obtained. Now, why did you think that you were using a geometric distribution in part A?
Because it's rolling a die until a 5 is repeated, so there's no.
Okay, so until a 5 is, so the first 5, that's how you got it, right?
Yeah.
Now notice how we're going to find the probability that a 5 is again first obtained after the third row. All right, now this tells me that we're still talking about a geometric distribution. Because what I'm interested in is the first 5, only the first 5, okay? So what was the probability of success?
Yeah,
1/6, right?
yeah.
Okay. Now, if I wrote the probability statement, what would it look like? I want to find the probability that X is what?
Greater than 3.
Greater than 3. Okay. Now, do you remember the formulas? Oh, wait a minute. What else though?
But before the 8th throw.
Okay, so let's change this. The probability that X is before the 8th throw, but after the 3rd throw. Yes?
Yep.
So let's break that down. I want to know the probability that X is equal to what? What's the first number I would be wanting to know about?
Greater than 3.
What individual number would I want to know about? Do I want to know about 3? Does it include the number 3?
Oh, no. You want X greater to be 3. You want
All right. So what's the next number after 3?
X has to be less than 8.
No, what's the number after 3?
Oh, 4.
I want to find out the probability that X is equal to 4. Okay.
Mhm.
Now, what's the next number after 4?
5.
I want to find the probability that X is equal to 5. What else is after 5?
6.
What else is after 6?
7.
Now, do I want to find the probability that X is equal to 8?
No.
Because I don't want to go that far, do I? I want to know the probability of it being a number between 3 and 8. Yeah?
Mm-hmm.
All right. So what's going to happen is we're going to do these, again, separately. How do I find the probability of a geometric distribution?
You do
How many failures do I have to have? If on the 4th time I have my first success.
Wouldn't you use that one formula?
Well, just think about this. Work with me here. What's the probability of getting a 5?
1 6.
What's the probability of not getting a 5?
5 6.
Exactly. Yes?
Mm-hmm.
Okay, now, if the first time I get a 5 is on my 4th throw, how many times did I fail?
4 no. Yeah, 4 times. No.
On the 4th time I had my success, how many times did I fail?
You failed 3 times.
So
right?
I'm going to do 5/6 times 5/6 times 5/6, which is 5/6 to the 3rd. Yes?
Mm-hmm.
Then after I have my 3 failures, what do I have?
1 6.
A success, but only one of them. Yes?
Mm-hmm.
Now, this is the probability of having my first success on the 4th try. What's the probability? How would I figure out if it was my first success wasn't until my 5th try? How many failures would I have to have?
4.
And then I would have my 1 success. Yes?
Mm-hmm.
Tell me about this one. What if the first time I have a success is on my 6th try?
And then you failed 5 times.
Yeah?
Mm-hmm.
What if the first time I have a success is on my 7th try?
Then you failed 6 times.
Right. Yes, you get me?
Yeah.
All right, now, here's what I'm going to do. In your calculator, type in 5/6 to the 3rd times 1/6. What do you get?
I got 125 over 1,296.
Give me a decimal.
0.0964.
0.0964 what? Give me one more.
5.
All right, because I want to go at least 4 significant figures, okay? This 0 doesn't count. So I'm going to go 1, 2, 3, 4. You with me?
Yep.
Now, in your calculator, go back now and change that 3 exponent to a 4, and then figure out the new answer.
That gives me 0.08037.
Okay, now go back in your calculator and change that 4 to a 5th power.
It gives me 0.06697.
And then go back in your calculator and change that 5 to a 6th power.
Gives me 0.05581.
All right, now, this is the probability of happening on the 4th, the 5th, the 6th, and the 7th. If I want to know the probability of all of those numbers, I got to add them up.
All right, yeah, that makes sense.
Okay, now, you were mentioning the formula.
Mm-hmm.
The formula for a geometric probability looks like this. The probability that x equals, we'll say n, is going to be the probability of failure, which I'm going to say is q, okay? Probability of failure to the n minus 1 time. So whatever this number is, it has to fail 1 less time than that. And then the probability of success. And do you notice that's exactly what we did?
Yeah.
Now, the thing is, what I say is, if you think about what's happening, there are 3 failures and then a success. It's not a formula you have to really memorize, because if you think of it this way, then, you know, if my first success was on the 7th try, then I must have failed 5, 6, 5, 6, 5, 6, 5, 6, 6 times, and then had 1 success. Does that make sense?
Yeah, that makes sense.
All right, so then tell me about this next one.
That would be a binomial distribution
Why do you say that?
because there are a set number of trials.
Exactly. All right. So now what's happening is that to find the probability that a 5 is first obtained in fewer than 10 throws. So let's think about this. Find the probability that a 5 is first obtained in fewer than 10 throws. Now let's go back up here, because I spoke too quickly. Find the probability that a 5 is first obtained between the 3rd throw and the 8th throw. Now, why didn't you think those were trials?
Because I was looking for the first obtained, so it could go.
Exactly. But are we still looking for the first obtained?
Oh yeah, but like there's a, and here there's like a set, there's a limit.
Well, but wasn't there a limit up here?
Oh no, yeah, geometric.
Okay, this is still geometric. Okay,
Yeah.
so let's go back over here and look at this. Find the probability that a 5, again, it's first obtained. Now, if it's a binomial, they're not going to say the words first obtained. They're going to say, find the probability of getting a 5 in fewer than 10 throws. Find the probability of getting a 5 in 2 out of the 10 throws. But they're not going to say the first one, okay? So whenever they're talking about the first one, and again, you have to be careful because they can try to trick you, and there are ways to word it. But if it says the first throw, then we're probably still talking about geometric. So let's think about the probability statement now. The probability that x is what? Less than what
10.
number?
10.
Okay. Now, again, there was 2 formulas that one formula that I told you about a minute ago, that's on the formula sheet, okay? When they want to find the probability that x is equal to a number, it's going to be the probability of failure to the n minus 1 times the probability of success, okay? That's actually on your formula sheet. However, there are two other formulas that were not on your formula sheet. One is if the probability of X is greater than a number. If the probability of X is greater than a number, for example, let's say this, find the probability that X is greater than 3. All right, now, how many failures must I have had?
2.
It's got to be, now keep in mind, my first success doesn't happen until after the third throw.
Oh, so three failures.
Failures, right?
Mm-hmm.
If I'm going to do this, then this is going to be the probability of failure to the third power. Okay? If I want to know the probability of a number greater than a number, then the only thing I know is that there was a certain number of failures. There are n failures. Q to the n power. You with me on this?
Yeah.
Okay. Now that's not what they talked about. Now let's reverse it. What if I go like this and say the probability of everything else that's less than or equal to n? Well, all I'm going to do now is take, because remember, all the probabilities have to equal one number. If I take all the probabilities, they equal 1, right?
Mm-hmm.
So if I take 1 and subtract the probability of it being bigger than this, these are two formulas that are really going to be helpful to know, but they're not going to be on your formula sheet. So here's the trick. Do you notice how this doesn't say less than or equal to?
Mm-hmm.
So what number, how can I write this so it still meant the same thing, but instead of saying less than 10, it was less than or equal to some other number? Give me a number that's less. What are the numbers that are less than 10?
9.
And 8 and 7 and 6 and 5, right?
Mm-hmm.
Now, what else could I say only less than or equal to, but still get the same numbers? What if I said it was less than or equal to 9? Now let's go back up here. What are the numbers that are less than 10? 9, 8, 7, 6, and so on. Yes?
Mm-hmm.
What are the numbers that are less than or equal to 9?
No, the same thing. 9, 8.
Okay,
6.
you with me on this?
Yeah.
So it looks different, but I end up with the same exact numbers. Now, my formula has this. So what am I going to do? 1 minus, now what's the probability of failure?
Would it be? Would be 5, 6, right?
It's still 5, 6, right?
Yeah.
Okay. And then to what power?
To the 9th.
These two formulas like, for example, what if I reworded this and I said, find the probability that the first 5 is obtained in greater than 5 throws. The first 5 is greater than 5 throws. Well, see, now it looks like this. And all I'm going to do is the probability of failure to this number, to the 5th.
Yeah.
Okay?
Mm-hmm.
All right, you got any other ones?
Yeah.
What else?
I got Oh, it's the coding data. I had no clue what to do. It was the very first test.
The first one. Oh, I see it here. Here. This one here?
Yeah, number 2.
All right. So when I have coded data, what happens is I've added some number or subtracted some number from each one of my data points. Okay?
Mm-hmm.
This means the sigma in front means that I've added all this stuff up. So let's talk about finding the mean. How do I find the mean of anything?
You add the number of things divided
Add
by
up the numbers and divide by what?
the number of things.
The number of numbers, yes?
Yeah.
Okay. Now, if I take a number, let's say the number's, I don't know, we'll make it easy. 1, 2, 3, and 4. What's the average of that?
Oh, wait. You got all of them, right?
Add them up and divide by 4. What do you get?
10 divided by 4. We get 5/2 or 2.5.
Right, 2.5. Okay.
Mm-hmm.
Now, what if I add some number to each one of them? What if I add a 3 to it? This would be a 4. This would be a 5. This would be a 6. And this would be a 7. Add those up. What's the average of those?
5.5.
And it's going to be 9 plus 13 divided by 4.
Mm-hmm.
Okay. How are these two numbers different from each other? How far are they apart?
3.
And do you notice that's the number that I added to each one of my numbers? Okay.
Mm-hmm.
If I have data points and I add the same number to every one of the data points, the mean is going to go up by that number. If I have some data points and I take away a number from each one of my numbers, I take away the same number, my average is going to go down by that number. Are you with me on this?
Yeah.
So let's take a look here. I've taken, the thing is, in this case, I don't know what number it is that I have added or subtract. I know it's subtracting, okay?
Mm-hmm.
But if I add it all up, what did I get?
520.
And how many values are there?
40.
All right, so what I need to do then is figure out the average. And so what I'm going to do is go like this. $520 divided by how many?
40.
All right. Now that's going to give me the average that's been lowered by this number. Are you with me on that?
Mm-hmm.
Now, what is the average?
34.
Okay. So the actual average before I took away the number is 34. So what I need to do is take 520 and I need to add back whatever number I took away. What's 520 divided by 40?
13.
So this is going to now be 13 plus K equals 34. What's K got to be?
21.
K is going to be 21. If I were to take this number, 21, and added it to the mean, or added to this coded thing, I would get 34. Does that make sense?
Yeah.
So the thing is, that must be this number that I have taken away from every data point. So K is going to be 21. Does that make sense?
Yeah.
So if I went like this, because sometimes these problems look like this. And I'm kind of making this up, so I don't know how this is going to work. Okay. And what if I told you there was 30 pieces of data? Now, in this case, I'm telling you what I'm taking away. Are you with me?
Mm-hmm.
Now, if I asked you to find the mean, the actual mean, well, first what I would do, it was like take this 500 and I would divide it by the number of pieces of data I have. What's the number of pieces of data I have?
30.
Okay. Now, that's going to give me a mean that's too small because I've taken away 4 from every one of the numbers. Okay. So then what I've got to do is add 4 to whatever that is.
Mm-hmm.
What's 500 divided by 30 plus 4? I don't know, some weird number.
20.666. Yeah.
Okay. Now they'll probably figure it out so it won't be like a decimal like that. Okay. But what I'm saying is that a lot of times what they'll do is they'll show you something like this and they'll ask you to find the mean. What you do is take this number, divide it by the number of numbers, but then add back whatever they took away. If this had been a plus, well, then I would have subtracted it. Does that make sense?
Yeah.
Now, the only difference in this question is they're telling me what the mean is and not telling me what I took away. So I'm still going to do kind of the same thing, only I know the mean. I'm not trying to find the mean, but I don't know what this number is. So I'm just putting plus K, but then I have to figure out what that is. They're just kind of reverse of each other. All right.
Yeah.
Now, if I'm going to find variance, how do I find variance of numbers?
Isn't it the
I'm going to add up all the x's squared.
divide by the number of things.
I'm going to divide by the number of things, and then I'm going to subtract what?
So from the mean squared.
And what I'm going to do is I'm going to make it the sum of the x's divided by n. Because isn't that the same thing as the mean?
Yeah.
But then I am going to square it. Okay, that's the variance. Okay. Now, when you have got coded data, you're just going to use the coded data. Now, what's my k?
21.
All right, so now it says, let me change colors here. So now this is actually going to be the sum of x minus 21 is equal to 520. And this is going to be the sum of x minus 21 squared is equal to 9,640. Okay. Now, like I said, if I want to find the variance, I literally am going to do this exact same thing, only I'm going to do it with these values I've got. So instead of it being x squares, it's going to be x minus 21 squared. What's the sum of all the x minus 21 squares?
9,640.
And what's my n?
40.
Okay. Now, what's the sum of my x's?
520.
If they give you this, now again, if you have to find the variance, they're either going to give you the k's and the c nodes. In this case, you have to figure it out. But if you have to find the variance, then all you do is take this information and treat it just as if it had been actual numbers. If they want a standard deviation, then I would square it, root it.
Yeah.
Don't get me wrong, that's confusing.
Yeah.
All right, man. I'm gonna have to get out of here. It's been good working with you.
Yeah, thank you, Mr. Cross. It means a lot.
All right, have a good one now.
Yeah, you too.
All right.